In the first video, we learned about the Ship Captain Crew game and wrote the Python code to model this game. In this video, we are going to update that code and test different playing strategies using Monte Carlo simulation. And in the end, we are going to determine the best and the worst strategy. So, assume that we have 3 people, each playing the game with different strategies, alright? Then the first person follows the strategy that we implemented in the first game. Let's call this strategy always roll, meaning no matter what combinations we got in the first 2 rolls, it will always go with the third roll. The second person follows the opposite strategy. Whenever the person scores the ship, captain and crew, then completes the game immediately. And the third person follows a balanced strategy. After scoring the ship, captain and crew, this person only rolls the dice when the sum of the remaining 2 is lower than 7. We will implement these 3 strategies and run the game many times to estimate which strategy works better. So let's begin. This is the code that was developed in the first video. Let's keep the code as is and create a new class named Ship Captain Crew v2. It will be with the exact same code, like here. Let's create another cell and paste the code and put a title here. Strategy implementation. Okay. And let's call this v2. And let's make some changes. First, let's remove the print lines here. So let's remove this one because we're gonna run this many times, so that we don't want to print everything at each run. Okay. So we renamed the class, we deleted prints. Now we're gonna implement the strategies. So the easiest implementation of the strategy would be on the play method. So here we can add a parameter called strategy. Okay, and then here let's rewrite what strategies we had. So we said strategy 1, which says always roll. Strategy 2 is except the first time when the ship, captain and crew is collected. And strategy 3 here is reroll when the score is lower than 7. So assume that when the strategy parameter is 1, it means strategy 1. When it's 2, it means strategy 2. And when it's 3, it means strategy 3. Okay? So we know that this code was the original one and it should be the strategy one. So we say if strategy equal to 1, then this will work. And if strategy equals to 2, now we are talking about except the first time when the ship, captain and crew is collected. In that case, we will do something similar to this one, but slightly different. So we know that we need to have allowed rolls. That's fine. But at the same time, we only roll when the score is equals to 0. So this means when we do not have the ship and captain and crew at hand. Okay. And finally, third strategy. It's going to be similar to this one, so let's copy and paste. And here, again, we will keep this, but only when the score is lower than 7, we'll keep rolling. Okay? So this is the third strategy, and this is it. So all strategies could be captured this way. Now, we will create a new function here. Monte Carlo runs. Okay, and we identify here number of runs. Okay, inside this function, we wanna keep track of the scores of each player. So let's create a variable called scores and np dot 0. So initially everybody has the score of 0. So we have 3 players. Okay, and for each player we have strategies, right? So let's call these strategies. 1, 2, and 3 are the strategy IDs. And now we're going to create one game, and let's call this Ship Captain Crew V2. Okay. And for each player, so we need to create a for loop for I in range 3. Here we can just print player ID. So we can say like player I. And now we're going to run this many times. So let's create another for loop. But now we are going to use number of runs. Okay, number of runs that is passed to this function. In each run, we're going to play the game. And using this strategy that is identified here. So the first player is playing with the strategy 1, second player with 2, and third player with 3. Okay, so we can use I as the index that comes from player ID. Okay, and in the end, we're going to update the scores. Okay, scores I game.score. So you remember we had a class level variable called score, and this score is updated after the evaluation. So when we call the score here, we get the final score that comes from the game. Okay, and after running these 3 players, we're just gonna return scores. So this is the Monte Carlo code, and we're just gonna run that code and call this with let's say 1000. So we are running each player strategy 1000 times. Okay. Oops. Oh, the class is not defined. Okay, we have to run this cell as well. Invalid syntax. Okay, there's an error. Okay, let's fix it here. Syntax is good. Let's run. Okay, let's run this. Okay, strategy is not defined. Oh, we call it strategies. Sorry. Okay, let's run. So the first player, player 0, had this total points. The second player had this total points, and the third player had this many total points. Let's run this one more time. So you see the results have changed a little bit. Since we are running this 1000 times, if we divide the scores by 1000, we'll get the average score per game. Okay, so results are similar. So the first strategy looks similar to the second strategy. It's a little bit worse than the third strategy. And if we run it again, now we get a little bit different result. Now the first strategy is way better than the second, and the third strategy looks like the best. So in this respect, the problem is that we don't know how many runs are sufficient. So we get mixed results. And in the next video, we're going to tackle this point and come up with repeated runs that would allow us to estimate the results a lot better. All right, see you in the next video.